Hey, howdy, howdy, howdy. Learning target very similar, if not identical, to yesterday. We want to solve some equations and maybe have some other fun stuff going on using some of our identities of the sine and cosine functions. You might be sitting here with the entire class, in which case you can all watch together. Or if you're by yourself, you've got the link off Schoology and you can watch it at home or use earbuds or headphones or whatever in school. And you can either decide to do one question at a time and then check your answer, or maybe you just want to do all four questions at once, then check your answers. Or maybe you're like, hey, I kind of want to work with step by step, and you can do that too, right? You can always stop, pause, rewind as often as you want. So without further ado, here is question number one. If you try and want to work on it on your own, I suggest you stop the video or at least hit the pause button. Otherwise, here I go. I'm going to go through this step by step. First thing I need to do, of course, is which identity? For sine of 2 theta, I really don't have much of a choice. I have to use 2 times sine theta times cosine theta. Now, what should I do at this juncture? I see a common factor of sine theta. So my common factor goes out in front. That leaves me with a 2 cosine theta. A subtraction. And 1. Remember, if everything factored out, you're left with 1. Sine theta times 1 makes sine of theta. Set up your two equations. Either sine of theta equals 0, or 2 cosine of theta minus 1 equals 0. Of course, the equation with cosine, I can add 1 to each side and then divide by 2. And so either sine of theta is 0 or cosine of theta is 1/2. Flying through the trench at the Death Star, it looks like we could be at 0, pi over 3, pi, or 5 pi over 3. Same thing with number 2. If you want to try this on your own, please stop or pause the video. Otherwise, I'm going to go through this step by step. Now, this is a little bit more interesting because with cosine of 2 theta, I have to make a choice. And I'm like, well, in the equation I'm looking at for question 2, everything is in terms of cosine. And since everything is in terms of cosine, I'm going to pick the selection that just uses cosine. Right? Let's just keep everything in terms of cosine. So I will swap out my cosine of 2 theta, exchange it for 2 cosine squared theta minus 1, and now I've got an equation where everything is written in terms of cosine theta. It doesn't look right. I got to reorder that. I'll keep the 2 cosine squared theta first, but I'm going to move the plus cosine theta to the middle, and the negative 1 will be my last term. Looks like 3 terms, so I'll do 2 sets of parentheses. I know I need cosine times cosine for cosine squared, but there's a 2. So I'm actually going to use 2 cosine theta times cosine theta. That will create the 2 cosine squared theta. Easiest part is probably recognizing, hey, 1 times 1 makes 1. There's no choice on that. Now it's a little bit trickier. You know the negative on the 1 tells you the signs do not match. But these two don't look identical, right? One of them's got a 2 cosine theta. The other one just has cosine theta. So where do you put the positive? Where do you put the negative? I want 2 subtract 1 to get me a positive 1. So that's where I need to place the negative and the positive. Because I'm thinking when I do FOIL, that 2 cosine of theta has to multiply the positive 1. So that'd be O in FOIL. The I in FOIL would get us a negative 1 times cosine theta. So if we did FOIL, we'd get 2 cosine theta minus 1 cosine theta, which would leave us a positive 1 cosine theta, which is what we need in the middle. Thank you, multiplicative property of 0. I can separate this into 2 different equations, because if we multiply 2 factors and get an answer of 0, one factor had to be 0. Add 1, divide by 2. On the other equation, we just have to subtract 1. So we know either cosine of theta is positive 1/2, or cosine of theta is negative 1. Here comes the death hour. Again, on this one, everything is in terms of cosine, so I've got to identify where cosine could be positive 1/2 or negative 1. Notice this time we're only going to get 3 answers instead of 4. Theta could have been pi over 3, pi, or 5 pi over 3. Question 3, once again, if you want to try this on your own, stop or pause the video. Okay, if you're still with me, what do we need to do? Probably need to search for our inner Bob Ross here, right? Let's paint a picture. I need an X and Y axis. My triangle better go in quadrant number 2. Theta, of course, is always at the angle that's at the origin. Sine theta is opposite over hypotenuse. So opposite of theta will be a positive 4. Hypotenuse would be a positive 5. Remember, the hypotenuse, by definition, is always positive. How did I know quadrant 2? Well, in the question, it says I have to be between pi over 2 and pi. So that's how I knew that this was the quadrant to draw that triangle in. Pythagoras will come give us an assist. Now remember, although it's a squared plus b squared equals c squared, don't get in a hurry and also assume that you add. Here we don't actually want to add the 16 and the 25. Here we actually need to subtract because we're missing one of the legs, right? If we need the hypotenuse, we add. If we need one of the legs, we actually subtract. And so the length of the third side of the triangle would be 3. But I got to think, I'm in the quadrant plane, and I've got 4 quadrants. And I got to think about, hey, well, the Pythagorean theorem might get me an answer of 3. Because I'm in quadrant number 2, the value will actually be negative 3. And of course, we already knew that the sine of theta was 4/5. But now we know that the cosine of theta, adjacent over hypotenuse, will have to be negative 3/5. Sine of 2 theta, there is no choice. Sine of 2 theta must be 2 times sine of theta times cosine theta. Well, we know what each value of those would be. Since one of the 3 factors is negative when we multiply and find the product will be negative. Numerator, 2 times 4 times 3 will get us a 24. Denominator 5 times 5 will get us a 25. So the value of sine of 2 theta will be negative 24 over 25. Now, if someone out there is like, wait a minute, I thought sine was positive. Yes, in quadrant number 2, sine is positive. And angle theta is in quadrant number 2. But we're looking at the value of sine of 2 theta. 2 theta is not in quadrant number 2, right? If theta is somewhere between pi over 2 and pi, also known as 90 degrees and 180 degrees, well, if we double that, it's got to be somewhere between 180 and 360 degrees. That's quadrants 3 and 4. So 2 theta has to lie somewhere in quadrant 3 or 4. Therefore, sine of 2 theta must be negative. A little more interesting because with cosine, you're like, hey, cosine of 2 theta. Are you going to be quadrant 3, which would be negative, or are you going to be quadrant 4, which is positive? Because I'm not real certain where this angle 2 theta is lying. I'm also not too certain which choice should I use for cosine of 2 theta. Trick question, it doesn't matter. Right? I can plug in my values for cosine and sine into any one of the 3 options, and I will get a value of negative 7 over 25. Right? Is this wild or what? It doesn't matter which of the 3 identities I use. We will get the exact same value, negative 7 over 25. So since both the x and y values are negative, angle 2 theta is actually somewhere in quadrant number 3. Question 4 again, same deal. If you're not ready, stop the video. Otherwise, let's proceed. 4 terms, so I'm kind of thinking factor by grouping, but I'm thinking, that 2 theta is really throwing a wrench into things, right? That 2 theta doesn't match theta. And so I'm thinking, well, I got to make a trade, and which trade do I want to go to? Well, that sine squared of theta kind of sticks out like I don't belong. Is there some way that we could eliminate that sine? Right, I have to make a trade because the 2 theta does not agree with the theta. And I'd like to rewrite everything in terms of cosine. So there's my choice. Right, because that negative sine squared of theta will cancel the positive sine squared of theta. So as I make my trade, and I rewrite this, well, first of all, I got to keep my 3 cosine squared theta. I'll keep the plus sine squared theta. Here comes my trade. Cosine of 2 theta gets traded for cosine squared theta minus sine squared theta. And of course, I still have my subtract 3. I still have my equal sign. I still have my 0. The positive sine squared theta and the negative sine squared theta will cancel. I can also combine like terms. So the 3 cosine squared theta plus cosine squared theta will become 4 cosine squared theta. And of course, we still have to subtract 3 and the equal 0. Let's add 3 to each side of the equation. Let's divide each side by 4. Let's take the square root. Again, if I'm going way too fast, you know how to pause, you know how to rewind. Right? Up on top in that numerator, square root of 3 we're going to be stuck with. On the bottom, also known as the denominator, square root of 4 will become 2. Plus or minus, because I don't know if we're thinking positive times positive or negative times negative. A long time ago on a unit circle far, far away. Again, make sure that I'm looking at cosine, and I'll take either positive or negative root 3 over 2. And so it's all of the over 6s. Right? Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. I'll be back in the classroom tomorrow. And we'll actually do something a little bit new and different tomorrow. Woohoo! But that wraps it up for today.